Welcome you all in this today's session. Today we have started new chapter from Engineering Chemistry Spectroscopical Technique Part 1. In this spectroscopical technique, we have started with UV visible spectroscopy. This UV visible spectroscopy deals with two laws. First one, Lambert's law. Lambert's law states us that when beam of monochromatic light passing through transparent solution, then decrease in intensity of incident radiation is directly proportional to path length at constant concentration. Important terms in Lambert's law, they are using monochromatic light. Monochromatic light means light which having single wavelength. So what is meant by the single wavelength? If we having the source of light, suppose here we having source of light, that light having different radiations, different wavelength of radiation, we convert that light into single wavelength by using a monochromator, or here we call as a slit. Then from that single wavelength light, if I pass through transparent solution, see over here, this monochromatic light passing through transparent solution, here we are using transparent solution. If we use the transparent solution, then decrease in intensity of incident radiation. Consider this incident radiation is I0, and decrease in intensity of that incident radiation, here decrease, so we are written di by I0 is directly proportional to dx. So remember this, here we are having decrease in intensity of incident radiation is directly proportional to path length. Path length means the size of this curve. This denoted by dx. Here di by I0 is denoted by A, that is absorbance, and path length is denoted by x. So we are having one relation, A is directly proportional to x. Beer's law says that when a beam of monochromatic light passing through transparent solution, then decrease in intensity of incident radiation is directly proportional to concentration at that constant path length. Guys, be with me. Here I am having the same solution. In one way, in the previous one law, they want to say that this cavity size, we have to change the cavity size every time. Be with me. If every time cavity size goes on increasing, number of particles in this area goes on increasing as compared to first one cavity, second cavity we having higher particles than third. In third one we having more particles than second one. So path length goes on changing means this cavity size, be with me, this cavity size goes on increasing. This cavity size goes on increasing. As the cavity size goes on increasing, number of particles in that area goes on increasing. Obviously, our transmittance goes on decreasing, absorbance increases, number of particles increases, absorbance increases. Straightforward phenomena is related to Lambert's law. In Beer's law, when a beam of monochromatic light, again I having the source of light, this is my source, I convert that light into the single wavelength by using of the monochromator. Now this single wavelength light passing through this solution, decrease in intensity of that incident radiation, whatever the intensity, that I0 goes on decreasing, is directly proportional to concentration of that solution at constant path length. Guys, when I have to convert this cavity to this one cavity, first one cavity to second one cavity, first one to second one, at that time cavity goes on changing means I have to change the instrument, and every time changing of instrument is not possible. So instead of changing the instrument, we are changing the concentration. So cavity size is now fixed, and only we are changing the concentration. Here we are taking the different concentrations. Firstly, suppose if we are taking the 1 molar solution concentration, afterwards we are taking 2 molar concentration, then afterwards we are taking 3 molar, and according to that we are identified this law. Be with me. If concentration goes on increasing, number of particles goes on increasing in that area, so absorbance is directly proportional to the concentration of that medium. So we are having new formula for it. Thus di by I0 is directly proportional to dx. That's all for today's video. We'll meet for the next video shortly. Thank you.